Welcome back to 3R Ballistics. Today we got a little bit of material science and terminal ballistics. We're going to be using some common materials and some uncommon projectiles. And we really want to take these common materials to failure. So some of them we've used before, fiberglass. Some of them are new, stainless steel sheets. But we want to take a surface area of about 8 by 10 and try to get the same weights of each of these materials. So the stainless steel, while we do have one that's 14 gauge, to get it at 2 pounds, which was our target weight, 8 by 10 at 2 pounds, it didn't quite meet the needs. 16 gauge was way too light, 14 gauge was close, and eighth of an inch was way too heavy. And so that's why we used the materials and the combination of materials that you'll see. We used fiberglass, stainless steel with sheet metal in the back, stainless steel with polycarbonate in the back, and we have a control of just plain aluminum, 1/4 inch aluminum, and polyethylene, a level 3A body armor plate. Now, while the polyethylene does come in quite a bit lighter, we know what that can control. All the other materials, we want to see how they fail. And that is why we're using these uncommon, a little bit higher than what NIJ would consider a level 3A threat. But let's go over those projectiles now. Now, the projectiles we're using. So we're going to go ahead and try some specialty rounds. First up are the 5.7 rounds. The 5.7 rounds right here, we have a SS-198 LF, which is a green tip. It's a lead-free 27 grain 5.7 by 28 projectile. Here we have a Dragon Fang, which is basically a 34 grain copper projectile. Looks kind of crazy. And then in 9mm we have our Underwood. This is a plus P plus 115 grain, should be going about 1,300 feet per second. And then we have the Fort Scott Munitions plus P 80 grain solid copper 9mm. Now after we test those four, we have a big boy. We are finishing off with a 460 Smith & Wesson Underwood ammo 220 grain Extreme Hunter. This thing should be going right around 2135 feet per second per the box. That is closer to a light rifle round. But if that one doesn't go through these, we do have one other 460 that we will finish off with. But just to give you a comparison of these two, this is the Underwood ammo 9mm, and this is the 460 220 grain Extreme Hunter. We're really trying to stick with size and weight, not thickness. We're not going so much with thickness. As you can see, this metal is much thinner than the fiberglass. It's strictly surface area and weight. And these projectiles are a little unique, way outside NIJ standards, some of them, but that's why we want to use them. We want to see failure methods and what happens with each material. So today we got a little material science and terminal ballistics. Let's get out to the range and see what we can do. Okay, like I said, we're back out at the range. We're going to start with the fiberglass, since that is our kind of control. The 5/7, like I said, we got the green tip. I believe this is a 30-some grain lead-free, and we got the Dragon Fang from that is from Vanguard Outfitters, solid copper. So we're gonna start. Okay, safety off. Here we go. First green tip. we were a little high. We had the green tip right here, the SS198LF, and the Dragon Fang right there. And, uh-oh. Did it go through? That is why we have the clay here. Let us see. Oh, baby. Yow. That, yeah. That did not stop the Dragon Fang one bit. Okay, so that's the back. Oops, sorry about that. That's the back. Even though it's a very minimal hole out of the fiberglass, it's a very decent size hole and straight out the back. All right, let's move on to the 9mm. So we've already defeated the fiberglass, but now we got some Fort Scott munitions, tumble upon impact solid copper, and the Underwood ammo. I believe this is extreme penetrator. We'll take the shot with the Fort Scott first, and then we will go on to the Underwood. We're gonna go lower left this time. 1,608. 1325. Clear? So, we're gonna go lower left this time. This is the Fort Scott munitions right here. This right here is the Underwood ammo. Let's see what we got for those ones. Oh, baby. Oh. Yes, indeed. We got 2 more holes. Oh, yeah. This is starting to look like Swiss cheese. But we're not done yet. We got to hit this with the 460. Let's see what a little bit of energy does to this fiberglass. Okay, now we got the 460. All of these have been exceeding the NIJ standards. This one by far exceeds it. Woo! 1,951. Clear. We decided to go ahead and put a water jug behind this one because we basically knew that was going to go through. Went through the water jug. And what is left of our clay? Let's see. Ouch. Yeah, that's the 460 right there. Yeah. Okay, so we were able to stop the green tip of those specialty rounds. Let's move on to one of the other plates. Okay, now we got up the 14 gauge stainless steel with a 20 gauge sheet metal behind it. Again, we're starting with the green tip 5.7, and then we'll go right to the Dragon Fang. Dragon Fang went 2,298 feet per second. This was the Dragon Fang. This was the green tip. We had a failed attempt at the green tip here, and it skirted out the top. You could see where it initially hit right there. It created a big old damage spot. Dragon Fang obviously went through, but after we reshot the green tip, It is stuck right there on, ow, it's hot, on the front, right there. Okay, onto the 9mm. Okay, we got tumble upon impact first, Underwood ammo second. Here we go. 1665. The stainless steel isn't holding up too well. We're gonna go down to a 124 full metal jacket. These roughly go 1150 feet per second. And let's see what we can get with this. Here we go. All right, walking up to this, what do you know? It is standing right there. We were able to stop 124 grain full metal jacket. And obviously this is the tumble upon impact, which that one went straight through also. Let's see what we get with the other metal. Okay, so we're stepping these down. This is now 16 gauge stainless steel with 3/8 polycarbonate, no, I'm sorry, 1/4 inch polycarbonate behind it. Still 2 pounds, like all of these. But we're gonna start with this green tip and see if it could stop this, and then we'll move on. Good? Yep. Here we go. Here we go. 124 grain full metal jacket, 9mm. See if it can stop this as well. We'll also put this on the left side. Right here is the 5.7 green tip poking out a little bit, and there is the 9mm full metal jacket. As you can see, neither one of those went through, so we're going to go ahead and do 9mm Underwood ammo and see what we get with that. Extreme penetrator. We're going to go on the top right. Woo-hoo-hoo. There's the Underwood ammo, 9mm, straight through. And that would have been this one up here, Underwood ammo. Might be somewhere in there. We'll try to find these, show you what we got. Let's move on to the aluminum plate. Okay, we got a 1/4 inch of 6061 aluminum. We got the green tip 5.7 by 28. Let's see what we get. Good. Good. Here we go. .2237. These suckers are just flying. That's the first one to go through. So we're stepping it all the way down. Once again, 124 full metal jacket. Let's see what this ends up doing to aluminum. Good. Yep. We're going dead center. Whoa. Yep, we're going dead center. Whoa. And here you go. That is a very interesting result. So that's the green tip, which went through, as you can see, the plug for the aluminum was actually on the back of this like that. Meaning, hopefully in the slow-mo you can see, I guarantee you the 9mm ricocheted back. But that is, let's see the deformation on that. Yeah, that's gonna be hard to tell. We haven't cleaned up the clay. All right, on to the level 3 plate. Okay, we got the green tip. See what we get. 2054. Now we got the dragon fang. We'll put this top right. Ooh, 2107. We have the green tip here, the dragon fang right there. We went ahead and re-smushed the clay, so we'll see. Huh. Looks like it stopped them both. And it did. Whoa. Okay. First one to stop the dragon fang. It's a little mushy there. But we're gonna go on to the Underwood ammo and the tumble upon impact. Okay, we're gonna do the tumble upon impact first, and then the Underwood ammo extreme penetrator next. 1327. Clear. Walking up, this is the 80 grain tumble upon impact Underwood ammo extreme penetrator. And ho! I think we stopped them both. We stopped them both. Okay, on to the 460. 220 grain Underwood ammo. Here we go. You good? Good. Woo! 1938. I saw dirt come up behind it. We are clear. Here is the 460, and that is straight through. I mean, that's a hole in that thing, obviously. Obviously, this is not rated for that at all. It is actually not rated for a bunch of these. But that 460, oh, baby. Oh, whew. Yeah. Okay, we're back from the range, and we're gonna do a tear down on some of these plates. I do feel I need to explain a little bit more what the testing was done. We weren't so much trying to stop all these specialty rounds. We were definitely trying to see the modes of failure of each of the materials. There is a next step that we're going along with this, so we needed to see how these plates would fail, and I'll explain a little bit more on this. This one was able to stop one of the 5.7 rounds, the green tip, which is, you could see probably through there. It went through, I don't know, 2/3 of that at least. It was a speedy little round. Dragon Fang went through the 9mm. and obviously the 460. What is interesting though, and this is the whole reason of this test. This is what we want to see, is how it fails. These tend to break. They don't have elasticity. There's very little ductility. So it does have a little bit of expansion, but when they break, it's like glass. They just break through. They do seem to contain it a little bit more. I still want to use this as a strike face and see how it works with the other material behind it. But that's what we are doing with this one, which goes on to the next one. The aluminum, which wasn't necessarily anything other than to prove a point. When the metal by itself, bare, and I use 6061 because it does have a little bit more ductility. I don't know if you can kind of see the bend in there. It's got a little bit of bulge in the back, but same thing, when it's done, it plugs out. The metal actually plugs out. There was a piece that we found that was with it, so that's another mode of failure with it just plugging out. It almost creates another little projectile that comes out through here. So that's just 1/4 inch 6061 aluminum. Next we have the stainless steel. Now this is as some of these bullets fly off of here. So next we have the stainless steel. This was 14 gauge stainless steel with sheet metal behind it. And what I want to do, so what I want to do with this one is take the tape off just to show you that was the stainless steel behind it. And this is the ductility that I'm talking about. Right here. This one did not go through, but it's bulged out quite a bit. Also on the stainless steel did not go through. Yes, so as you can see, this is the stainless steel, 14 gauge. This is 20 gauge, basically sheet metal. And these two together. So once again, the higher power, higher energy rounds were just plugging out, which then moves us on to one of the unique ones. This had stainless steel, only 16 gauge stainless steel, and it had polycarbonate in the back. Polycarbonate is a material that is more ductile than the metal, and the metal itself is even thinner than the 14 gauge, so this was actually able to stop a little bit more. So taking these apart, we were able to stop the green tip 5.7. As you can see, it's got a little kind of a metal piece in there. I was able to stop the 9mm, but the Dragon Fang was able to go through. And once again, this is the ductility we're talking about. It's able to conform to the energy of that plate. And here you can see what I'm talking about. It was starting to plug out, and the polycarbonate was able to keep it intact. And now this Tactical Scorpion Gear level 3, which was able to stop all of them except the 460. And once again, once it fails, it just breaks through. It needs a bunch to slow it down. We'll take this apart now so you can see. Give me a second. Took a lot of my glove off, but anyway, as we can see, this 460 was the only one to go through. Not much back face deformation. We had the two 9mm tumble upon impact, and the Underwood extreme penetrator. We had the dragon, I believe the dragon fang was here, and the green tip. So the 460 was the only one to go through, and it held them real good. I mean, this is still pretty rigid. Okay, looks like we got a lot of the front off, and they're still a little bit further in there. Whoa, whoa, that dragon fang went pretty dang far. I'll put that one down here. That's the dragon fang. Here's the green tip, which has lost all its copper. Tumble upon impact. Ooh, not so sharp anymore, that tumble upon impact. And the Underwood. And there we go. And there is the Underwood Ammo Extreme Penetrator. So surprisingly, the one that went the furthest was the Dragon Fang. The second furthest was the Tumble Upon Impact. And then the green tip and the Underwood ammo were roughly halfway into the plate. So if you guys have stayed till the end, I appreciate it. In conclusion, I personally learned quite a bit. I was learning how to use certain materials for our next project. Our next project is going to be a fun one. We are going to try to turn old medieval, knight's armor into modern body armor, and that project has already started. We're going and testing that one in the next few days, and I hope within a week or so I'll be able to have that video out as well. And we're going to be throwing just as spicy rounds, rifle rounds, some AP rounds, and some heavy material. So if you guys are still here, I appreciate it. Like, subscribe, check out some merch if you want to help out the channel, and until the next one.